I'm going to evaluate the integral of x squared minus y squared dx plus 2xy dy along the closed curve C in the positive direction, where C is the boundary of the region, which is defined as the set of points xy such that x is between 0 and 1 and y is between 2x squared and 2x. So we have that region there and that integral. To evaluate this integral, I'm going to use Green's theorem. It states that if C is a piecewise smooth, simple closed curve bounding the region R, P, Q, partial derivative of P with respect to Y, partial derivative of Q with respect to X are continuous on R, then the integral of P dx plus Q dy along the closed curve C in the positive direction is equals to the double integral over the region R of partial derivative of P with respect to X minus partial derivative of P with respect to Y. So looking at the P dx here and compare it with what we have in our integral here, we see that our P there is equals to x squared minus y squared. Then go on and look at the Q dy here and the dy where we have our integral there. And then by comparison there, we see that our Q is equals to 2xy. Then go on and evaluate the partial derivatives. So for the partial derivatives there, we would have the partial derivative of P with respect to Y is equals to minus 2y. The partial derivative of Q with respect to X is equals to 2y. Then go on and substitute these values that we have just obtained. We put them here. And then we have the double integral over the region R of 2y minus 2y dA. So the 2y minus 2y gives us a 4y. So our integral becomes the integral over the region R of 4y dA. So that's the integral that we have now. But for us to clearly see our limits, sometimes it's better to sketch the region that we are talking about. So the region that we have is this region here. So for that region, I can just plot so that we have our x here and put a 0, then put the 1. Since our x is varying from 0 to 1, then we go on and plot the y-axis. So I label it the y there, then label it 2 there, then plot the y is equals to 2x squared, then label the 2x squared, then I label the y equals to 2x. And then the region that we are talking about is this region here, the region bounded by those curves. So that's our R there. And inside that region, we are seeing that x is varying between 0 and 1, and y is varying from 2x squared to 2x. So what I'm saying there is in the region R, x is varying from 0 to 1, and y is varying from 2x squared to 2x. So we are having the 2x there is our upper limit, is the one which is on top. So we then go on and look at that double integral there. To evaluate double integrals, you should recall that if f is a continuous function, then the double integral over the region R can be broken into the single integrals, where we have the integral from a to b, then the integral from c to d of f of xy dy dx, which will be equal to the integral from c to d, the integral from a to b of f of xy dx dy. What is happening there is on this first part here, we first integrate with respect to y. And on this part here, we integrate first with respect to x. On choosing which integral to integrate first with respect to x or with respect to y, we have to choose the integral with variable limits is the one that we integrate first. So in this case, the one that is variable limits is the y here, which is varying from 2x squared to 2x. So we evaluate first with respect to y. So our integral is of this form here. So that it becomes the integral from 0 to 1, the integral from 2x squared to 2x, then 4y dy dx. What we are saying there is we are integrating the integral with variable limits first, which is this one. So we are integrating first with respect to y. So for that integral there, what we would have is the integral from 2x squared to 2x of 4y dy it will give us a 2y squared. So it's 2y squared, then put the limits 2x squared to 2x. And when we put in the limits, the result that we get is 2 times 2x squared minus 2 times 2x squared squared. And that will simplify to 8x squared minus 8x to the power 4. So we substitute this into the highlighted part here, and we get the integral from 0 to 1 of 8 times x squared minus 8 times x to the power 4 with respect to x. And then we go on and integrate with respect to x there, and the result that we get is 8 divided by 3 x cubed minus 8 divided by 5 x to the power 5. Then put the limits 0 to 1. So when you put the limits 0 to 1, the result that we get there is